How do you find the margin of error? Well, there are three different kinds, three different situations. They all go back to what we learned about in Chapter 6 last week, that um, if you have a random sample and you have, those conditions are met, you have a normal, the proportion, the sampling distribution for all the statistics, whether you're dealing with means, x bars, or p hats for proportions, will form a normal distribution around that mean, that center, whether it's a population proportion or a mean. We don't usually know what that mean is, so that's why we use confidence intervals to come up with an estimate of it. So how do you get the standard deviation into that sampling distribution? Well, let's see. What we're going to do is for means, because this is a problem situation about means, they're telling me, I'm reading that there's a standard deviation. I also know that this comes from the population. So that tells me it's going to be a situation where I'm going to use z-scores. So for that formula, to get the margin of error, and that's what you asked about, so that's what I'm going to show, you take the critical value of z, in other words, what z-score cuts off the middle 99%. Dr. Stevens gave us a little shortcut table we'll look at in a minute. Then to get the standard deviation for the sampling distribution, you take your population standard deviation, which we denote with that symbol, that sigma symbol, and you divide it by the square root of the sample size. And so then, as you can see, as the sample size gets larger, you're dividing the same number by a larger and larger number, so this gets smaller, which pulls your margin of error smaller. So let's calculate this. Well, let's see. So we've got to come up with a 99% confidence interval. So I guess the first thing is let's go get a z-score. The bottom of that normal curve table, I don't have what page it's on, but it's in the back of the textbook. You're going to see this little mini table, which is extracted from that larger table. And when you have a z-score of 1.645, that cuts off the middle 90%. In other words, we would be looking at a distribution where there's 90% of the distribution falls in the middle and 5% falls on each side to make a total of 100%. Same thing with the 95, puts 2.5 on each side. 99 puts 0.5% on each side. We're looking for a 99% confidence interval, so I'm going to be using 2.575 as my z-score. So 2.575. And then we're going to multiply that. Let's see, the population standard deviation was 10.2. And we divide that by the square root of 35, because there's 35 pieces of data. Now, how do we calculate this? Well, one way is to go right to Google, search for calculator, and then you can key in right on the pad, do 2.575 times 10.2 divided by, then there's a square root key of 35. You hit equals, and that will be your margin of error. Now you can do this backwards, working backwards on a handheld calculator or depending on a calculator, but using Google is the easiest way to do this, and that way I know you have access to that. Okay, so that's the margin of error for this problem, and you can look at the answer up in the book here. Okay, situations about proportions. When you're trying to estimate population proportion. And notice that some things I notice, there's no mention of a standard deviation or a mean in this problem. So that tells me this is about proportions besides looking in the book. But if you're looking at a problem and there's no context, look for this word standard deviation, and if you see it, well, then you know you're dealing with means, or it'll either be z-scores or t-scores. This is about proportions, so it's a similar kind of thing, find some critical value of z. Then the standard deviation is slightly different, and it's related to the binomial distribution standard deviation we were talking about a couple weeks ago. So what we do is we need to find p hat. What's the sample proportion? Let's see, in this case of what percentage of what proportion of people called the phone number after watching the advertisement. So they did 474 people out of 1,512 made the phone call. So that's our sample proportion. That's our sample. And we could write this as a percentage, and it's not wrong to write it as a percentage, but to do the calculation, I think it's easier to leave it in decimal form. So I'm going to divide that, take the top number divided by the bottom number. So when I did that, I got 0.3135 or so. Now what I'm going to do is I'm going to leave this in my calculator. I'm only going to write down those 4 decimal places, but I'm going to let the calculator carry all the decimal places. So then we know the first part of this formula is a 3.135. Now we're going to multiply it by Q, Dr. Stevens calls it. All that means is we're going to take 1 and subtract this answer from it. And again, I'm going to let my calculator carry more decimal places. So 1 minus that amount, I'm getting 0.6865. And I know my sample size was 1512. And it's not letting me erase that, so I'm just pretend that end's not there. I'm going to write 1512. So now what the math you're going to do is you can do this again right on Google. You can do this times this divided by that, hit equals, and then take the square root of that answer. So what am I going to get? So this part of this formula is giving me 0.011931. I rounded a little bit, but I'm going to let my calculator carry that. Now, what z-score do we need? Well, a 95% confidence interval. This is the z-score. We're going to use that little mini table we just used in the last problem, and we're looking for a 95% confidence interval, so my z-score is going to be 1.96. So that's what I'm going to multiply my standard deviation by. And then you can round. So if you were to carry this all in your calculator and then round to the end, that'll give you the best answer, especially for proportions, because of the rounding can throw you off so much. Okay, so that's that kind. So now we're dealing with a situation when we don't know the population standard deviation. See, they're telling all this information is coming from this random sample of 35. So in order to account for that extra variability, we need to use the t-distribution. Now here's the part A out of that one, and I wanted to look at part B to help you get the margin of error. So to get the standard deviation, we're going to do the same thing that they did here. See where they did standard deviation from the sample divided by the square root of the sample size? So that's what we're going to have to do here. The one that's going to change is this critical value of t. We are going to go, in order to be a 99% confident, we have to go out further distance away from the middle, because it's in the higher level of confidence. So how do you get that off that table? Well, I know I've got a sample size of 35. In order to get the number of degrees of freedom, and that's how we account for some extra variability from not knowing the population standard deviation, to get the degrees of freedom, we're going to take our sample size minus 1. So we're going to take 35 and subtract 1 is 34. So we need to remember two pieces of information here. Our 34 degrees of freedom and our 99% confidence interval. So now we're going to go look at that T table that's in the back of the book. So I went and grabbed that table, parts of it, that table. So what I'm going to do is, remember, I'm looking for a 99% confidence interval, so I'm going to go down that column. And then I'm looking for 34 degrees of freedom. And when I line that up, I see that I need to use a t-score 2.728, and that's what's going to get multiplied by that standard deviation. So 728. So that t-score times the standard deviation of 10.2 divided by the square root of 35. Okay, so that's how you get the margin of error for the t-distribution. So I hope that helps you out.